The Fekkovich type curve approach is extremely powerful as a qualitative diagnostic for production data. The coordinates are logarithmic, so we have logarithmic rate versus logarithmic time. And the approach involves basically flow regime identification. So really what we're looking for here is the shape of the data. And there are indicators that we can get on a log-log plot that we simply can't see on linear plots or simple decline plots. For example, this downward concavity that we see in the data is indicative that the well is going into boundary-dominated flow. That's very important to learn whether your data is transient or boundary-dominated flow before we go ahead and try and model it or learn reservoir characteristics. The type curves that are in the background also tell us some information. For instance, all of these stems that are in the top left-hand corner are transient stems. The ones that are in the bottom right-hand corner are boundary-dominated stems. Each of the boundary-dominated stems represents an ARPS decline curve with a different hyperbolic exponent, or b-value. Our job as an analyst is to take this data and match it on the type curves as best we can. Once we have a good match, we can click on the automatic type curve selection button and extract some numbers. But again, the important thing here is not so much getting the numerical values, but understanding the qualitative diagnostics, or learning something about the flow regimes of this well. So we've learned that because the data has rounded the corner, so to speak, it's well into boundary-dominated flow. Now, Fekkovich makes the assumption of an empirical decline curve analysis for boundary-dominated flow. So we're not evaluating in-place fluids or pore volume or anything like that. We're simply going to get EUR and a production forecast. On the transient side, we can also get things like permeability and skin. Let's move on to Blasingame. The Fekkovich type curves were the first real type curve approach to production analysis. Blasingame and his colleagues came along a little bit later and enhanced the Fekkovich approach significantly. What they did is they added the influence of flowing pressures into this type curve matching procedure. So the type curves themselves are very similar to Fekkovich, but the data that we're plotting here now includes the effect of flowing pressures. So we have normalized rates, and the rates are normalized with the flowing pressure drop, PI minus PWF. And then in addition to that, instead of just plotting against regular time, we use a special production time or material balance time. And what that does is that takes variable rate data and turns it into an equivalent constant rate solution. It's a little bit like superposition. The idea being that if we do this, we can separate the operating conditions from the reservoir problem. This is a huge advancement in terms of production data analysis. It used to be that if you analyze production data at different rates and different operating conditions, you would have to break it into segments to really fit a decline to any particular component. If the operating conditions changed at a certain point in time, you'd have to use a different decline curve or a different type curve. Blasingame's approach ensures that we can use the same type curve all the way through the data set and decouple the operating condition changes through time. It's a very powerful procedure. In addition, the Blasingame procedure does all of this analytically. You'll notice that there are no multiple boundary stems. There's only one single stem. The solution for boundary-dominated flow on the Blasingame type curves is based entirely on analytics. For constant rate flow, that means a harmonic stem or a slope of 1 on that boundary stem. When we match our data to that stem, we can determine the gas in place for a gas well or the oil in place for an oil well. So in addition to getting reserves and a forecast, we can also determine the in-place fluids, which can be very valuable if we're trying to determine whether a well is in need of production optimization. For example, if the recovery factor is very low. Again, we'll go through and click on our automatic type curve selection. This will extract a specific type curve solution and allow us to determine permeability, skin, drainage area, and original gas in place. It's really an effective tool because you can very quickly get a handle on a lot of holistic production performance indicators very quickly by just doing a very simple type curve match. Let's move on.